on probability distribution today? Okay, so we're going to be discussing a few questions. Okay. Two fair dice are thrown. Let the random variable x this is your hint that it's a question on probability distribution. Let the random variable x be the smaller of the two scores. If the scores are different, and same value if the scores are identical. Construct probability distribution table. Okay. So what this question is saying that you throw two dice and let's say the outcome is 3 and 5. So then your score would be 3. And let's say the score is 3 and 3, then the score is going to be 3. Okay, so we have to construct the probability distribution table. So that starts with making two rows. So first row is x and the second one is probability capital X equals to X. And the top row, you write all the outcomes. So the difference could be 1, or the score could be 1, the score could be 2, score could be 3, score could be 4, and score could be 5, and the score could be 6. Okay. Now you have to find the probability that the score is 1. So how do we get 1 from two dice thrown and you select the smaller of the two numbers? So these are so many possibilities. What if it's 1, 2? Then also the score is going to be 1. What if it's 1, 1? Then also score is going to be 1. Even if it's 2, 1, then even the score is 1. If it's 1, 4 or 4, 1 or 1, 3 or 3, 1. So there's so many cases in which the score is going to be 1. It's a very bad idea to write all of them together and then find their individual properties and add them. Instead, what we'll do, we'll take help of this diagram. I'm going to write all the outcomes here. 1, when you throw a die, you get 1 or 2 or 3 or 4 or 5. And when you throw a second die, you get 1, 2, 3, 4, 5, and 6. I've missed 6. Now, what is X here? X is choosing smaller value of the two values on the dice, or the same value if the result is the same. So this diagram is called possibility diagram. This helps you finding the probabilities quickly. Possibility diagram. Okay. So when the first die has an outcome of 1 and the second die has an outcome of 1, then the score is going to be 1. Similarly, for 2, 2 score is 2, 3, 3 score is 3, 4, 4 score is 4, for 5, 5 score is 5, and for 6, 6 score is 6. And other than that, when the scores are different, we choose the smaller number. So in 2 and 1, the score is going to be 1. In 3 and 1, the score is going to be 1. 1, 1, 1. Then two, in between 2 and 1, the score is going to be 1. Then again 1 here, then between 4 and 2. So, sorry, we're choosing the smaller number. So here the smaller number is 1, here the smaller number is 2, here's the smaller number is 2, then again 2, and then again 2. Here the smaller number is 1, and it's always going to be 1 here, and then the smaller number is 2, and then the smaller number is 3, 3, 3. And then smaller is 2, smaller number is 3, and then 4, 4. Smaller number is 2 and 3 and 4, but 5 here between 5 and 6. And here the smaller number of between 6 and 2 is 2, then 3, then 4, then 5, and that's it. Now we have so many ones here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 ones, and there are a total of, count these, these are going to be 36 outcomes. So probability of getting a 1 is now very clear. It's 11 over 36. Unfortunately, it's not letting me press Control Z, so I won't be able to undo what I did. Okay, that helped. Okay, then how many 2s are there in the data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So it's good. The probability is going to be 9 by 36. Then how many 3s? 1, 2, 3, 4, 5, 6. So 7, in fact. This and this. So 7. So 7 over 36. Then how many 4s? 3 plus 2, 5. So 5 by 36. Then how many 5s? 3. 3 by 36. And then how many 6? Just 1. 1 by 36. And like we discussed before, if you want to check whether this is right or not, add them up and you should get 1. So 11 plus 9 plus 7 plus 5 plus 3 plus 1 would be 36. 36 over 36 is 1. So that means most probably this is correct. In the next part, you might be asked to find the expected value, which we've discussed earlier, is summation x times pi, which would be 1 times 11 by 36 plus 2 times 9 by 36 plus, that's 36, plus all the way till 6 times 1 by 36. Okay. And then you might be asked to find the standard deviation, which is square root summation x square times its probability minus square of the expected value. Okay, so we're not getting into that. I just wanted to revise the formula with you. Okay. Next question is, this is relatively more advanced. I should have it in the worksheet, just a second. This is a past paper question, not a book question. Let me take a look. Probability की worksheet में question है. Remember when we were doing probability worksheet, I was making you guys skip questions on probability distribution. So now we do them. Yes, it is there. Thank God I won't have to write it down. Okay. Okay. Chalo. Okay. So a fair dice has four faces. One face is colored pink, one is colored orange, one is colored green, and one is colored black. Five such dice are thrown, and the number that falls on a green face are counted. A random variable x is the number of dice that fall on the green face. Show that the probability of four dice landing on a green face is this. Correct to four decimal place. All right. So probability of getting a green uh, probability that the dice lands on a green face up is going to be 1/4, and probability that it does not land on a green die would be it would either lie on the orange one, it would either fall on the pink one, or the black one. So that's 3/4. Okay. Show that the probability of four dice landing on the green face is this, and there are total five dice thrown, I believe. Okay, yes. So we have to find the probability that uh, one of the dice falls on a green face, another one falls on a green face, another one falls on a green face, another one falls on a green face, and one does not fall on a green face. So this would be 1 times 4 times 1/4 times 1/4 times 1/4 times not green, which is 3/4. However, there are four more cases as well where four of the dice would be green and one of the die would not be green. So that is green, 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 not green, green, and similarly green, green, not green, 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 not green, 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 and not green, 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 green. So what you do, you multiply this with 5. And that should give that result. 0.0146. Let me just confirm. Okay. Yes, that is correct. It does give the result. Acha. Up. What if there were two of these which were not green? For example, it was green, 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 and not green and not green. So then there would be so many other cases where these not greens would spread out. Like there were 5 cases when the not green term was found. And here there would be many more cases where the not green terms would be found. For example, one case could be this green, not green, sorry, not green, 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 and then another not green. And then so many other possibilities as well. So you will have to find the number of possibilities and then multiply it with the probability. By the way, this working that we've started is for part 2. So I'm just trying to make you understand that why do we need to multiply this number? And in every case, we'll have to multiply a number. Now the trick to remember that कि हर केस में हम कौन सा नंबर अपनी प्रोबेबिलिटी के साथ डिवाइड मल्टीप्लाई करेंगे so that we account for all the possible cases. That is found by using combinations. So even here, instead of 5, I could have written there is one non-green ball. What was that? Dice, sorry. One non-green dice, and there are 5 possible positions where this non-green dice could land on. So that would be 5C1. So instead of 5, I could have written 5C1, and that would have given me 5 as well. So when we're talking about two non-green outcomes, then these two non-green outcomes also have 5 available spaces they could be arranged on. So that would be 5C2. So we'll find this probability and we'll multiply it with 5C2. Similarly, if there are 3 non-greens, then we're going to do 5C3 and then 5C4 for 4 non-greens and 5C5 for all non-greens. So now let's take a look at question 2, part 2. We will have to use this logic there. Okay. So what is part 2? Draw up a table for the probability distribution of x, giving your answer correct to 4 decimal places. Okay, so x, probability x equals x. And what is x? The number of non-green outcomes. No, the random variable x is the number of dice that fall on the green face. So what if none of the die fall on the green face? That's going to be 0 green outcomes. What if one of the die fall on the green face? 1. What if 2 of the dice fall on the green face? 2, or 3, or 4? I think there are total 4 dice. No, 5 dice. So that's going to be 5. Another one. Okay. So the total outcomes are 0 green result, 1 green result, 2 green result, 3 green result, 4 green result, or 5 green result. Let's find the first case, which is no green result. So probability x equals 0. That means there's no green result. That means non-green, 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 non-green. So that's going to be non-green की probability थी 3 by 4 power 5. And you don't have to multiply it with anything because there's nothing different here. So this is going to be 3 by 4 power 5 is 324 over 320, sorry, 243 over 1024. 243 over 1024. Okay. Then we're going to take the case where one of the dice is not green. So not green, 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 and green. Okay, so that's going to be probability. What's the probability of getting a non-green dice? 3 by 4. And then probability of getting a green die is 1 by 4. Again 1 by 4, again 1 by 4, again 1 by 4. So it's going to be a power of 4. And we multiply it with this non-green. This one value or this one outcome has 5 possible spots it can be on. So it's going to be 5C1. Just give me a second, I'll be right back. Okay. So, okay, the one was non-green and 4 were green, and we got this result. Let me check the answer. For this is going to be Achha, I'm sorry, I made a mistake. When it says x is equals to 0, that means there's no green outcome. But when it says x is equals to 1, that means there's one green outcome. So ये मैंने गलत केस कर लिया. ये मैंने 4 green का कर लिया. Let me just quickly fix that. There is just one green outcome. So it's going to be green, and the rest of them would be non-green. So probability of green is 1 by 4. Probability of non-green is 3 by 4. And that gets times with 4. And then there's one green outcome out of 5 available spaces. So 5, C, 1. Which is equals to 405 upon 1024. Then there's a case where there are 2 green outcomes. So 2 of the dice have green at the top, and the remaining 3 dice do not have green at the top. So that's going to be 1 by 4 times 1 by 4 times 3 by 4 power cube and times 5c2. Because these are 2 and there are 5 spots, so times 5c2. This gives 90 over 1024. Next is probability x equals 3. That means 3 of the dice have green at the top, 2 do not have green at the top. So 1 by 4 cubed, 3 by 4 squared into 5c3, which gives this one is actually 90 over 1024. The other one is different. Let me fix that. 90 over 1024. And the other one, this one is not 90. Oh, this one is in fact, what does it say here? 270 over 1024. So this one is 270. The other one is 90 over 1024. Then probability x equals 4. That means 4 of the dice have green top and one of them do not. So 1 over 4 power 4, 3 over 4 power 1 into 5c4, which gives 15 over 1024. And last, probability x equals 5, which is going to be all are green. So that's just going to be 1 by 4 power 5. You can write 5c5 with it, but that's just 1, so it's optional. And this is equals to 1 over 1024. Now, if you add all the probabilities, you'll get 1. And that's a confirmation that most likely we haven't made any mistake. Okay, one more question like this. And then we're done with this topic. This is from the book, so I'll have to copy it. A box contains 4 red balls and 5 yellow balls. Five balls are drawn without replacement. The random variable x is the number of red balls drawn. For the probability distribution table. Okay. So 5, 6, 7, 8. 8 balls are there in a box. 4 are red, 5 are yellow. Five balls are drawn from the bag without replacement. The random variable x is the number of red balls drawn. So you have to write the outcomes and the top row and the respective probability in the bottom row. So x is the number of red balls drawn. So there is a possibility that no red ball is drawn. All 5 balls drawn are yellow. There's a probability that one red ball is drawn. The remaining 4 balls are yellow. There's a probability that 2 red balls are drawn and the remaining 3 balls are yellow. Similarly, 3 red balls are drawn or 4 red balls are drawn. No more than 4 because there are a total of 4 balls only. 4 red balls only. So that you can't draw more than 4 red balls. Okay, so now we find the probability that no red ball is drawn. So that means it's going to be yellow, 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 and again yellow. So probability of getting a yellow is 5/9. And it says without replacement. So the probability of getting a yellow again is now going to be 4/8. Then 3/7. Then 2/6. Then 1/5. Now this gives, let me check. 1/126. Okay. They're all yellow, so we won't do 5C anything. You could do 5C5, but that's just one. So then it's going to be probability x equals 1. That means only one red ball is drawn. So I'm going to write red and then yellow, 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 yellow. Okay, so the probability of getting a red ball is going to be 4/9. Then probability of getting a yellow ball is going to be 5/8. Then 4 here, then 3 here, then 2 here, and denominator is 7, 6, 5. And you multiply this with, this is one red spot, but then there are 5 availabilities for this red ball to be. So that's going to be 5C1. one red ball and 5 locations, so 5C1, which gives 10/63. In fact, if I do not simplify the denominator and keep it as 126, it's going to be 20/126. I'm going to keep the denominator same because it's going to be easier to add it to check that the sum is 1. Okay, then it's going to be probability x equals to 2. That means 2 red ball are drawn and 3 are yellow. So, and this can be done in 5C2 ways. 5 locations for 2 red balls. Okay, so red's probability is 4/9, then 3/8, then yellow probability is 5/7, then 4, then 3 here, and then 6, and then 5 into 5C2, which is 60/126. Similarly, probability x equals to 3, red, 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 yellow, yellow, times 5 available slots for 3 red balls. Okay, so red probability is 4/9. And since it's without replacement, the denominator keeps decreasing. So 4/9, then 3 here, then 2 here, 8 here, 7 here, 5/6, and 4/5 into 5C3. Okay, this gives 40/126. Okay, next is probability x equals 4. That means 4 are red and just 1 is yellow. So 4/9 times 3 times 2 times 1, 8, 7, 6 into probability of getting a yellow ball is then going to be 5/5. And you multiply this 5C4. This gives 5/126. Now, if you add all of these, you'll get 1. Oops. And that indicates that no mistake was made while constructing the cumulative, the probability distribution table. All right, that's all for today. I'll inshallah see you guys tomorrow. We'll start binomial distribution. I believe the third last chapter. Allah Hafiz, take care.